Hello everyone, Assalamualaikum. Welcome back to my video. So in this video we will continue on chapter 1, which is enzyme. Okay, so let's begin. In my last video we already explained on the general characteristic of enzyme. Now let's move on to the relationship between enzyme and activation energy. The total of all chemical reactions that occur within our cell, we call it as metabolism. And metabolism can be divided into two types, which is catabolism and anabolism. We will take a look on catabolism first. Catabolism means that the reaction involves the breaking down of high energy substances into lower energy product. For example, complex substances broken down to form simpler substance. I'll give you an example, which is the hydrolysis of glycogen. Lysis means breakdown, hydro means water. So in addition of water, molecules of glycogen are break down to form its monomer, which is the glucose. And catabolism also known as exergonic reaction. While anabolism require and constant input of energy to convert low energy substance into high energy products. For example, simpler substances combine together to form more complex substances. I give an example, which is synthesis of glycogen. Synthesis, in other words, to build up. So to build up the glycogen from the monomer. What is the monomer? The glucose. So glucose plus glucose forming glycogen. Anabolism also known as endergonic reaction. Now let's talk about two different types of chemical reaction that occur in our cell, which is the exergonic and endergonic reaction. We take a look on the exergonic reaction first. Okay, I give you a diagrams of exergonic reaction. Y-axis is the free energy, while x-axis is the progress of reaction. Sometimes we call it as a reaction coordinate. Okay, exergonic is the reaction in which energy is released and the delta G has a negative value. How do I know that? We use this formula, which is delta G equal to energy of product subtract energy of reactant. Let's give a value. Let's say energy in the product 1 unit and energy in the reactant 4 unit. So using the formula, energy of product subtract energy of reactant. So 1 unit subtract 4 unit, we get negative 3. So the value of the delta G is negative and must be less than 0. Okay, delta G is negative value. While in endergonic reaction, the delta G must be positive value. So we give a value, energy of product, let's say 4 unit, and energy of reactant 1 unit. So 4 unit subtract 1 unit, we get 3, which is positive, and delta G must be more than 0. So in endergonic reaction, this kind of reaction require energy. Alright. Okay, so how does enzymes speed up chemical reactions? By lowering the activation energy. Chemical reaction is a process of forming and breaking of chemical bonds that leads to the changes of starting material. Sometimes we call it as substrate, sometimes we call it as reactant to form products. So chemical reaction must need or require in initial input of energy. So the bonds in the substrate can break or form. The initial input of energy, we call it as activation energy. The abbreviation of activation energy is EA. E and A must be capital letter, A subscript. Okay, with the presence of enzyme, the reaction runs in the same direction as it would without the enzyme, just more quickly. Okay, so here now let's take a look on this diagram. Here we have energy diagram. Y-axis is the energy, x-axis is the reaction coordinate. Okay, this is the reaction where it has a molecule, okay, forming two products. As you can see, without enzyme, which is the black line, without enzyme, which is the black line, a lot of energy is needed to make this reaction proceed. Okay, and the structure up here at the top, we call it as transition state. So what is the transition state? Transition state is the unstable condition of substrate either substrate break or form the bond. So during this state, substrates are activated, the molecules within the substrates are collide. So in order to make the successful collision between molecules of substrate, energy is required, which is the EA, the activation energy. Okay, so the enzyme, as I said before, it lowering the activation energy of reaction. So you can see the red line with a lower energy level. It means there is less energy needed by the substrate to reach the transition state and form products. So here another example of exergonic reaction, okay, with the presence of enzyme. This reaction can lower the activation energy and produce product more quickly compared to the reaction without enzyme.